Slope is a really important concept in mathematics and one you're going to be dealing with all the way through calculus. So what is it? Well, it's just a measure of how steep a line is either rising or falling. And how do we calculate it? Well, if I have 2 points, this one is x1, y1, and this one is x2, y2, then the difference in y's, the difference in y values is called the rise, and the difference in the x values is called the run. And the slope is change in y over change in x, or rise over run. It doesn't matter which point you subtract from which, but whatever you do first in the y, you have to use that same point to be your first x. So let's find the slope of this segment. All right, so slope, and we usually use the letter m for it. I don't know why, but that's just always what it's been. Change in y over change in x, which gives me 3/2. Notice that it's positive, and if we look at this line, it is increasing as we read it from left to right. That means it has a positive slope. Let's take a look at this one. All right, so change in y is 6 minus 1. Change in x is 3 minus 9, which is 5 over negative 6. Negative 5/6 is negative, and this line is decreasing as we go from left to right along it. That's why it has a negative slope. Okay, let's look at the slope of the line through these 2 points. So slope is change in y, negative 4 minus negative 4, over change in x, 8 minus negative 3, which is 0, over 11, which is 0. And if we graph these points, you notice that they have the same y-coordinate. That means it's horizontal. Horizontal lines have 0 slope. They're perfectly flat. They don't go up or down. Okay, let's take a look at these 2 points and the slope of the line that contains them. Okay, my change in y is negative 2 minus 9, and my change in x is negative 6 minus negative 6, which is negative 11 over 0. Uh-oh, we can't divide by 0. What does that mean? It means that this slope is undefined. Well, what kind of line has an undefined slope? Notice they have the same x-coordinate, which means that this would be a vertical line. Vertical lines have undefined slope. So now let's see how slope applies to parallel lines and perpendicular lines. Well, 2 non-vertical lines are parallel if and only if their slopes are equal. So the line going through these 2 points has a rise of 3 and a run of 5. Okay, and then if I draw another line down here and I go 1, 2, 3, 4, 5, and then up 3, these 2 lines are parallel. They will never intersect. They have the same slope. Okay, 2 non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. If I multiply them together and I get negative 1, then I know that those 2 lines are perpendicular. Another way to say that is their slopes are opposite reciprocals. Okay, so I'm going to draw a line, and I'm going to do a rise. I'll do a rise of 3 and a run of 5 again. Okay, so there's our slope, and you can see that that is 3, 1, 2, 3, 4, yeah, 3/5. Okay, now let's say that I start at this point right here, and I'm going to go negative 3. No, I'm sorry, opposite reciprocal. I'm going to go negative 5. 1, 2, 3, 4, 5, and over 3. 1, 2, 3. And if I connect those, I get perpendicular lines. So the slope of one line is 3/5. The slope of the second line is negative 5/3. And those are opposite reciprocals. If I multiply them together, the product would be -1. Okay, use slopes to show that a quadrilateral with vertices blah, 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 blah is a parallelogram. Okay, so let me draw my axes right here. Okay, point A is at -2, 7. So there's -2, and then 1, 2, 3, 4, 5, 6, 7. Point B is at +3, 7. Point C is at 6, 11. 1, 2, 3, 4, 5, 6, up 11. Whoops, let me get some more space here. There, okay. So I'm going to go over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's C, and D is at 111. Well, it looks like a parallelogram, doesn't it? How can we be sure? Well, let's check the slopes. So I'm going to get the slope of segment AD. That's going to be 11 minus 7, change in Y, over change in X. 1 minus -2. Okay, 11 minus 7 is 4. 1 plus 2 is 3. Now let's compare that to the slope of BC. All right, change in Y, 11 minus 7. Change in X, 6 minus 3. It's 4/3 again. Those are parallel because they have the same slope. Now let's compare the slope of DC to the slope of AB. Notice that D and C have the same Y coordinate. That means the change in Y is going to be 0. And AB have the same Y coordinate. So their change in Y is also going to be 0. And so they also have the same slope. Since both pairs of opposite sides have the same slope, they are parallel, and that is a parallelogram. In our last example, we're going to find the slope of each side of a triangle and the slope of each altitude. And remember that an altitude is perpendicular to a side. So let's get the slope of side AB. That'll be 4 plus 3 over 1 plus 1, which is 7/2. That means the slope of the altitude to AB will be the negative reciprocal because slopes are perpendicular to sides. Okay, let's get the slope of AC, and that will be 4 plus 5 over 1 minus 4, which is 9 over -3, which is -3. That means the slope of the altitude to AC is +1/3. And finally, the slope of the third side, BC, is going to be -3 plus 5 over -3 minus 4, which is 2 over -7. And that means that the slope of the altitude to BC is +7/2.